Hey guys, Professor Doney here, another installment of Physics Online YouTube. First problem we're doing here is spring mass system. This is in chapter 11 in vibration and waves. So we have a spring mass system. We're going to start out with a spring and we're just going to give it an unstretched length of 1 meter just so I have some easy numbers to deal with. And what happens is we're going to hang a mass on it. Let's make it 2 kilograms. And when we hang the 2 kilograms on it, we see that it stretches an additional 0.4 meters. Okay, just making up numbers here just so we can have a problem. Now, since it's a spring and we just put a mass on it, we have some forces going on. We're going to have the force of gravity, which is mass times gravity, pulling down on that spring. And the spring reacts by having a restoring force, which is the spring force, and it's negative in that direction. And that is delta x or k delta y. So what we can do is find out what the k value of the spring is by using that law, and that is Hooke's law. Hooke's law is going to tell us the relationship between the restoring force, which is spring force, and the weight. So we put the force of the spring is kx, and that's going to be force of gravity is pulling on it, kx, so that's mg is kx. Well, that should be an x up there, shouldn't it? And we'll have k equals mg over x. So what's that going to be? 2 times 9.8 times x. Now x is how much, is really a delta x, is how much it's stretched. And we see a stretch 0.4 meters, so we're going to have 19.6, wow, over the place today, over 4.4, and let's see, 19.6 divided by 0.4 gives us a 49 newtons per meter. That means it's going to take 49 newtons to stretch that every meter. Now we assume that k value is constant. So once we have the k, we have the k. We don't have to change it up, and it's going to be constant there. Now we can find a few other things. If we would stretch this, let's do a part B. If we would stretch this an amplitude of another 0.2 meters and then release it, the idea is that mass is going to start to oscillate up and down, and it's going to oscillate about that stretch point. Now the stretch point was 0.4 meters down. We go another 0.2, so it's going to go 0.2 down and plus 0.2 up. And we can find a few things from that. We could find out the total energy it's going to have, which is 1/2 Ka squared. That's energy is actually potential spring energy. So that's half 49.2 squared, whatever that comes out to be, and that'll be in joules. And we could also find what the frequency this is going to oscillate at, which from the spring mass equation is 1 over 2 pi square root of k over m. So that's 1 over 2 pi. Make sure you put that in your calculators. 1 divided by parentheses 2 pi square root of 49 over the mass is 2. And again, that would come up with some number that's going to be in hertz. And then we could find the period, which is 1 over frequency, and that would be in seconds. So I'm not going to give you the numbers there, the calculations. That's certainly something you can do. But it just talks about if we have a spring, we hang a mass on it, it stretches some additional amount here, and that's the delta x there. We can go find the k value, which we did, and then using the k value we can find a bunch of other things like total energy, frequency, and period. So hope that helps with the spring mass system problem, and we'll see you in the next video.